All right, here we go. Graphing. This is that four-step method. It's really quick once you get to know it. Okay. The derivative, y prime is equal to 0. So just y is equal to 2 times the negative, so that's negative 2x. And then just bring the number down, plus 4 equals 0. And then solve. So negative 2x equals negative 4. And then x is equal to 2. Okay? I shouldn't have to do all the steps anymore. These are like, you're getting closer to pre-cal. You should be knowing what we're doing. Okay? Algebra should just be in the head. Okay? This is your axis of sim. That means at 2, you have this dotted line. Okay? And somewhere on that dotted line is the vertex. That's that next step. Step 2 is the vertex. F of the axis equals the vertex.
Junior and senior going on the financial workshop, please report to the canoes now.
So F of 2 is equal to negative 2 squared plus 4 times 2 minus 2. Okay? Then you just figure that out. 2 squared is 4. Okay? So it's negative 4 plus 8 minus 2. These should be halves. They are, so that's good. Okay? Now, boom, 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 boom. That should be a 4 minus 2. Well, guess what? That puts us at f of 2 is equal to 2, which makes it 2 and 2. So that means right up here is your vertex. Right? Now, we should know by looking at this that it is frowning, right? So that means that this is coming down some way, somehow. Okay? We're graphing. That's all we want to do is graph, so we keep it simple. Right? 3, f of 0 is equal to c. So I just plug it in. F of 0 is equal to negative 2. I have my point. 0, negative 2. That's it. Okay? 0 and negative 2. That's my other point. It's going to come across and come down to here. That means over here, this same amount is going to be, so 3 and 4. So at 4, I'm going to be at negative 2. And I'm done. It's graphed. I mean, that's easy. Now, what does that mean? That means that four is f of 2 times the axis is equal to c. That means that 2 times that 2, right? That's the 2. So 2 times that 2 is 4 is equal to c. That means you should be at 4 and negative 2. But you should check it. Just check it quickly in your head. What's 4 squared? Well, it's the same as 4 times 4, right? But this one's negative. So therefore they cancel out. Boom. Easy. It's that simple, people. Okay? These are not hard. These are actually super easy, and that's why I put them on here. Because I want you to feel good about graphing quadratics. And then you can use your vertex formula. We had to learn it. We might as well learn it. We might as well know how to do it. Because on that SBAC, I guarantee you, they're going to put vertex formula. I guarantee you. Okay? So, you have to be able to look at this and go, oh yeah, the x's do the opposite, right? The x's do the opposite. So this is not right. This is left 2. Okay? And it's not, this is down 1. And so all it is, we look at the parent function. What's the parent function? It's a quadratic. Okay? So I should know that my quadratic looks like this, right? And it goes 1, 1, right? 2, 4. -2, 4. Okay? That's my quadratic. But this one is going to go left 2 and down 1. And at that point, it's going to go up 1, up 1, right? And then over 2 and up 4. 1, 2, 3, 4. And again, over 2 and up 4. And then there it is. And it's graphed. Okay? And that's exactly what I'm looking for. You don't have to plug in numbers if you don't need to. You should know how to graph the parent function. You should know how to move the parent function. Right? Left 2, down 1. Simple. Simple. It didn't ask you to stretch it, right? Once we stretch it, it's a little harder. Compress it, a little harder. But just moving it, left and down, right, up, cake. We got that all day. Bag of chips. Okay? And then degrees to radians. This should be easy too. Okay? Pi over 180, because pi and 180 are the same. Okay? If I'm going to radians, I want pi. If I'm going to degrees, I don't want pi. It's that simple. Okay? So, now I just had to break it down. What goes into both of these? Well, I know 10 does. So that'll bring me down to 102 pi over 18. And then I think about what goes into 102. Well, I know 2 does. I know 3 does. So I know 6 does. That's a start. Right? I'm sure 18 does, but we don't know. Okay? But I know, because this is 18, that 3 goes into it. I know 2 goes into it. I know 2 goes into 102. I know 3 goes into it. 1 plus 2 is 3. Okay? So if 2 and 3 go into it, what's 2 times 3? 6. So we know 6 does. 6 goes into 10 how many times? Once, with 4 left over, right? And 6 goes into 42 7 times. Okay? How many times does 6 go into 18? 3 times. So you're done. 17 pi over 3. Cake. Okay? And then you can think, how many pi's is that? If they wanted you to graph that, it's not hard. I'm breaking this up into 3 pieces. 1, 2, 3. Right? Let me do that in a different color. Okay? 1, 2, 3, 4, 5, 6. And this is 2 pi. And this is pi. Okay? And if I want to go to 17, I'm going to go around 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17. Boom. This is 17 pi over 3. That was not hard, was it? If we understand radians, it's really easy to graph these. Okay? Now, the other thing is, we know that that's 1,020. What is the reference angle, though? What's the reference angle? Right? So think about it. If I'm breaking 180 into 3 pieces, how many times does 3 go into 180? How many times does 3 go into 18? So it's 60. This is 60. So it has a reference angle of 60. Look at everything we just did. Just by knowing radians. Is that cake? Right? loves cake, man.
What are you doing?
All right.